Okay, we're in day 5, and I'm going to call this part 1. Use that. And so we're going to do some alternating series. What does it mean to alternate? It means like every other, like you guys are on A day and then B day and then A, right, alternating. So with us, when we talk about alternating, we're talking about the signs alternate, positive, negative, positive, negative, positive, negative. And so when we have an alternating series, we're going to be able to determine the convergence divergence, and then we're also going to have a series bound that's going to be really important to see like what we can approximate it to. So before I've shown you some of those bounds, but they've only been bonus. This one you actually have to know. So how do we get it to go positive, negative, positive, negative, positive, negative? Well, that's kind of like that. Oh, here, let me go down. That's kind of like that -1 to the n. As you plug them in, they alternate signs. And you could even put a negative out in front of it. They're going to alternate signs. They're just going to alternate where they alternated from. And then similarly, I mean, you can have this n to the 1. You could even have -1 to the n plus 10. Okay, but just be careful because -1 to the 2n, remember, that's just 1. So make sure that it's an odd form of that. Okay, so when you have an alternating series and when this sequence in here is always greater than 0, okay? So that's without the alternating part, getting like just looking at the absolute value of it, basically. Okay, if the limit of that part right here, if the limit of that goes to 0 and the next term is always less than or equal to the previous term, that's telling me that we have decreasing, then we can say that this converges by the alternating series. And remember, if the limit is not 0, then we know something else. We know that this diverges by the nth term test. Okay? And so for these two guys here, a lot of times we will say decreases in absolute value because you're getting rid of that negative to 0. And that's what these both mean, is that you are decreasing and you're going and going until you get to 0. Okay, so let's look at our first AP classroom. So if the limit is 0 and this term, oh, this is challenging. Look what they did. They flipped it. They said the next term is bigger than the previous term. And then they come down here and they kind of show some things. So if the next term is bigger than the previous term, well, let's divide over this a sub n plus 1. This is really fun. So this one just becomes 1 now. And let's again divide by the a sub n. Those canceled, now those canceled. And we get something like this. So now it's like this fractional form of the next term is smaller than the previous term of the fractional form. Okay, so let's go see what we have going on here. So which of the following must be true? Well, we had the limit is going to 0. And if I had 1 over a sub n, it's going to decrease in terms. So we know we don't want that one. This one doesn't have the alternating. This one doesn't have the alternating. So this would be an alternating series whose terms decrease in absolute value to 0, and that would be convergent. Okay, let's look at the next one. So this just wants me to determine it. And I see that it has the alternating part. So since it has that alternating part, I know I'm going to try the alternating series test. So we have to do two things. We have to take the limit as we go to infinity of the a sub n part, which is the non-alternating part. So that a sub n is going to be n over n squared plus 1. That limit is 0. So far we know nothing. Okay, just remember, just because the limit is 0, we know nothing about convergence or divergence. So then we get to move on to step 2. and we say, does the next term, is that always less than the previous term? Like this. And you can kind of check it out and try some things and cross multiply, and that is true for n greater than or equal to 1. So we can say that this whole series converges by the alternating series test. Okay, so the next one. I see the alternating part, so I'm going to do two things. I'm going to take the limit as n goes to infinity of the n over 2n minus 1, and this time I get out 1/2. Hold up, wait a minute. Okay, so that is not 0, so stop. We already know what happens here. This diverges by the nth term test. Done. Okay, so look at the next one. It wants to know what's going to be true. And so basically, if you're seeing convergence or divergence with that limit, so we know that when we look at these pieces, that the limit's going to have to go to 0. So we're going to have to be bigger on bottom. This one's bigger on bottom. Oh, this one is not. That diverges automatically because you're going to get 4 over 1. So that one's out. That doesn't converge. Let's see. Oh, here. That says diverges. That is wrong. That's going to converge. This basically, remember how we said is between 1 and -1? So that's going to converge. And then let's look at this one. Oh, hold on. This we said was, dang it. Okay, so this we said was between 1 and -1. So that's like -1 to the n again. Begin again. And when I see this, it actually is going to combine when I take that -1 to the n with the -1 to the n plus 1. That's -1 to the 2n plus 1, which is -1 to the 2n times -1 to the first. And remember that part's 1 times -1 is -1. The alternating went away, and this is just -1 over n squared. So this doesn't converge by the alternating series test. This actually converges by the p-series test. It is convergent because like we can see, but we got rid of the alternating. Okay, and this one, bigger on bottom, that one actually does converge, okay? And that was by the alternating series test. So the only one that really worked with everything was D. Okay, so that was the alternating series test. Now we're going to talk about the remainder theorem. And this is saying how close of an approximation can we get by taking just the few terms and doing a partial sum. So this S actually means S to the infinity, like forever and ever and ever. And so if we have a convergent alternating series, okay, so they're decreasing in terms of absolute value to 0. So we've got this. Then if I took and like, let's say I did the first 10 terms, then the actual infinite number of terms minus what we get for the 10 terms, and it's an absolute value, so you can flip-flop those. But that error is less than the next term. So we can, like, how close are we to seeing what it converges to? Well, we're close enough to say it's close enough by that next term. And it's kind of like the absolute value of that. It's just the a sub n part, not the -1 to the n. So if you want to think absolute value, you can, but it's just ignoring that -1 to the n. Okay, so let's see. This one says that this series converges to some S. So it's based on the alternating series error bound. What is the least number of terms that the series must be summed to guarantee a partial sum that is within 0.03 of S? So we're basically saying that this S, which is like S sub infinity, minus S to some n, we want it to be less than or equal to 0.03. So we basically need our next term to be less than or equal to 0.03. That's kind of the goal. So let's go out in some terms. Let's do a sub 1, plugging it in here. A sub 1 is going to be 1 when I plug in 1. Well, that's really far away. Let's jump down. I did jump to a sub 20 to see what happens. So I plugged 20 in here and use your graphing calculator and plug it in. I'll wait. Or pause me. And I got 0.223. Again, still pretty dang far away. So I kind of jumped and I said, I don't know why I did the numbers I did, but I said, what's 333 term? Okay, well, that is 0.05. I'm getting closer. So I kind of like jumped ahead again and I saw that the 1110, I just kept plugging some things in, was 0.030015. Okay, so we're really, really close. And then when I did the 111, I got 0.03000015, super close. And then when I plugged in this one, I got 0.029988. So that is finally smaller than this guy. So how many terms did I have to go to? I had to add up 1 to 1111, which is the number of terms I had to go to. So that would have been like the next term for the error bound, but it says how many do we have to sum to? So this would have been s minus s to the 1111 is less than or equal to the a sub 1112. So we had to sum to this number of terms. Okay. On this one, I found like it might be easier if you think of it as a decimal. And then I want you guys to try this one. And it's pretty similar to what we just did, and see what your answer is. I got C for my answer, and I want you guys to try that and see if you get it too. Okay, when you're done, you're ready to continue. Let's go to this next example. So it wants me to use the alternating series remainder theorem to approximate using the first 6 terms. Well, first we need to make sure it's a convergent alternating series. Do these terms decrease in absolute value to 0? So let's just write out some of the terms then. We have 1 minus 1/2. Let's do that was 1, 2, 3 plus 1, 6, 4. 4 factorial is 24. 1 over 24. 1 over 120. Okay, so I can see that the terms decrease in absolute value to 0. So we know that this is a converging alternating series. Okay, so now that we've taken care of that, let's go do, it said the first 6 terms. So let's go find S sub 6. And I had actually written them here, so we want to put these together. And you get to use your calculator on this. Not that you couldn't do it by hand. It's not that bad. But go ahead, use your calculator, add those up, pause me, and pause me when you're ready. And make sure you get this. So I know that the overall sum as I go to infinity minus what I just found of the 6 partial sum here is less than or equal to the next term. So if we went to 6, the next term is 7. So that infinite minus what we just found is less than or equal to the next term that would have happened. So that would have been if I plugged in my 7. And remember, we only want the absolute value of it, no matter if it's a positive or a negative sign. So we're just kind of looking at it here, not the -1 part. And 7 factorial is 5040, so this would be 1 over 5040. Sorry, absolute value. So we can approximate what that sum to infinity is Remember, we can get rid of the absolute value bars by negating. And then I'm going to go ahead and when I add that to both sides, I'm going to make it a decimal so I can see a little bit easier what this is kind of going to. And so far I can see that we're converging to at least 2 decimal accuracy of 0.63 just by going 6 terms. So of course we can get a better decimal accuracy if I went more terms, but we're saying that if I added this up here forever and ever and ever and ever, I know that it's at least 0.63 with certainty. And then I don't know the rest of the decimals yet. Okay, we would need to be more accurate and go out more terms. But that's pretty dang cool that you can find what that series is going to be close to just by this error bound. And just by looking at the 6, partial sum here, and only going out to the 7th term to help with the error. Okay, this next one's just kind of fun. It's to look ahead. If you see it has X's end-ins, this is all going to be in the part 2 of Unit 10. But I just wanted us to kind of look ahead so you could see what's going on, because it's going to talk about that alternating series error bound again once we get closer. And here it's telling me it's a 4th degree. We're going to be plugging in 1/2. So let's just write out these terms. Okay, so like go write out, plug in 1, plug in 2, plug in 3, see what you get. And pause me and just write them out, and then see if you unpause me if you get the same thing. Okay, so this is what I got. And then it just said, hey, go to the 4th degree. Well, the 4th degree stops right here. And that's what we're going to learn about for that Taylor polynomial. It just means they'll tell you what degree to go to. So here's the 4th degree, and it wants me to plug in 1/2. Okay, and it says that using the alternating series, what would be like the error here? So if I went for ever and ever and ever minus this, what I just found, that partial sum, then that has to be less than or equal to the next term. Well, the next term was this right here, but instead of x, I'm doing the same thing and I'm plugging in the 1/2. So just, something you could kind of think through on your own, but just to think ahead as we are connecting these, that it's not that different, okay? All right, so we're gonna stop there for that one, and we will start this part 2 of day 5 the next day.